Hi guys, looking at a couple more spectrum. So first thing that we look at with this combined spec problem is the molecular formula. We've got C6H4Br2, which gives us a U number of 4. So that's going to be a benzene ring most likely. And we're going to go up to the IR spectrum to just kind of corroborate that. There are some little overtones. Overtones. Likely attributed there. Okay, so over here, we're expecting to see, since there's only 4 H's, we're really just expecting to see CH stretching, sp2, like the double bond, which we usually see over on the other side of 3000. We usually see it over here. But we've got some dipole situations with 2-bromine, which just kind of make this whole signal here wonky. Its absorbance is much lower. You do see, this little peak here on around 3100, which is what we would expect. We would just kind of expect it all to be shifted over a little bit more, which is fine. Bromine makes IR spectrum weird. So that's all we're really going to find from this IR spectrum, because bromine doesn't show up in the visible spectrum. It shows up like over here at about like 450 inverse centimeters. So that's why in this particular spectrum problem, the IR spectrum is going to be of minimal use to actually tell us much about the structure. So, and the mass spectrum is also going to tell us minimal information about what we're looking at. So we're really going to concentrate on the CNMR and HNMR to tell us what is happening. And what we find with the CNMR is that it is very unusual in that there's no CH3 or CH2 signals. Nothing here or here. So we really just have CH. And since this signal isn't reflected in the DEPT line, this is just a C, a carbon, which we would expect since there's 6 carbons and only 4 hydrogens. We know that there's going to be 2 carbons with no hydrogens attached. So down at the HNMR spectrum, we see only 1 signal for the HNMR, which means between these two things, there's a ton of symmetry in this structure. So whenever there's a lot of symmetry within a aromatic compound, the first thing I look at is a P substitution arrangement. In this case, Br would be on either side there. So let's take a look and see if this will give us what we want. So look at all that symmetry. We really just have one type of hydrogen just repeated 4 times, which goes along with this. And we have one type of CH and one type of C. This is one type of C, one type of CH. So that goes along with that. It goes along with the right molecular formula. And yeah, so I think that this is our structure right here. And this signal needs to be labeled in that area, and then the CH will go in over here. So that is our first spectra, and that looks corroborated, but we can also do a search, which I did, and you can see for sure that that is the same spectra.